Okay, well, picking up on where we left off yesterday with the transformations, we're going to work on dilations today, and then we're actually going to go and do some review from yesterday with some more stuff. A dilation is basically scaling up or down of a shape, whether it be a physical object or like we're going to work on the beginning on the coordinate grid. So you're going to be given a center point, which on the coordinate grid is always going to be the origin. There are some other ones where you can kind of draw stuff on paper and have a center point and scale them that way, which is slightly different, but still kind of works out with how you do it. We're not going to go over those, but we're mostly going to be doing the coordinate grid, which the center point is always going to be the origin. So we're always going to, whatever our scale factor is to do a dilation in the coordinate plane is we're just going to take our x and y coordinates and just multiply it by that scaling factor. So it's just more of a multiplication process. Then you plot your new points and you have your new scaled up shape. Does that make sense? Everybody sees that? Like I said, the center point is always the origin. So here's our first example. We have these points. We want to graph we want to create a scale factor of image ABC after a dilation of a scale factor of 3. So first what I'm going to do is we're going to plot triangle ABC based on the vertices we've given on our coordinate grid. So I'm told A is at negative 3, 3. So here's my A value. B is at negative 1, negative 2. So there's my B. And C is at 3, 1, so here's my C. We have A, B, and C. So these are my points. I'm going to draw on my triangle here. So that's what our triangle looks like originally. I'm going to switch over to red color now to work on the new things where now our scale factor is 3. So we're just going to multiply our x and y coordinate by 3 to get our new things, our new points. So our new point A is going to be negative 3 times 3, so that becomes negative 9, 9. Negative 1 times 3 is negative 3. Negative 2 times 3 is negative 6. And 3 times 3 is 9. 1 times 3 is 3. So these are our new coordinates for our dilated triangle. So again, we plot those. So I go over to negative 9, 3, 6, 9, up 9, 3, 6. So here's my new A prime point, we're going to call it. B is at negative 3, negative 6. So I have negative 3 down to negative 6. So here's my new B prime. And C is over to 9, then up 3. 3, 6, 9. Yep. All right. 3, 6, 9. Yeah. So here's my new C point. So C prime. And again, we're just going to connect our points. So this is our triangle scaled up by a factor of 3. Does that make sense? Everybody kind of see that? That's all we're doing with dilations. Is what's our scale factor? Let's find our new points, plot them on a graph. So here's 2 for you to try. Again, it's graph the original factor, figure out what the new points are, and then graph your new image as you go through. Enter your, what I'm going to do is have you enter the new points for the shape in the Edpuzzle, and then come back and check and see how you did. Okay, so here are 2 graphs. The red is the original. The blue is the new scaled factor, the scaled image. So everybody should have gotten those pretty easily, I think. Okay. Here's another one to try. It's vertices, again with a scale factor of 0.5. Enter the coordinates of the new image into Edpuzzle, then come back and check and see how you did. All right, a little harder to see because the lines were bigger, but again, red one is the original point, the original image. Blue is the scaled down image. And then one last one for you to try, I think. Again, it's the same rectangle as before, just with a different scale factor. Enter the new coordinates in the Edpuzzle and then come back and check and see how you did. And here's what we should have gotten. I didn't graph it. I didn't label it this time, but this here is going to be your M, N, P, and Q. So this becomes M prime, N prime, P prime, and Q prime. Everybody seeing what we're doing here? Again, it's not that difficult at all. We're just multiplying coordinate grid points by the scale factor. All right. Sometimes you're also going to be given shapes and some information on some shapes, and you're trying to scale it up. So here we have dimensions. We're considering a square with side lengths of 4 feet. We're asked what the new side measurements would be if we scaled that square by 2.5. So here's my square. Each side is 4 feet. If our scale factor is 2.5, we're just doing 4 times 2.5. So we get now our new sides are going to be 10 feet. Does that make sense? And again, what are the new side measurements if we use a scale factor of 4? Well, here we're multiplying by 1/4, or we're dividing by 4. So our new square would have sides of 1 foot. Does that make sense? Okay, awesome. Here's one for you to try. You're given a cube, a 3 by 3 by 3 cube, a scale factor, and we want you to determine a new surface area and a new volume of the similar to the new cube. Enter your answers in the puzzle and then come back and check and see how you did. Okay, bad drawing of a cube, but you can see it's 3 inches high, 3 inches wide, 3 inches deep. So my new cube is going to have side lengths of, this is the old cube here. I didn't draw the new cube, but our side lengths are going to be 6 inches long now. So the volume of a cube is base times width times height. So it's 6 times 6 times 6, or 216 inches cubed. The surface area is going to work out to be the same thing. The area of each face is 36 inches squared. We have 6 of them, so I multiply 36 by 6, and again we have 216 inches squared as our surface area. It just so happens that that's similar. They're the same. Does that make sense on shapes? Okay, so here's now we're going to get into a little bit of a review from yesterday. There are 3 images on your board, your screen. Tell me for each one, what is the transformation type that occurred to move the dark colored square shape to the gray shape. So it was either a reflection, a translation, or a rotation. Enter in the Edpuzzle what you think they are, and then come back and check and see how you did. Okay, the first one for the L, it's just a reflection on the x-axis. The second one was a translation. It moved 5 units down, 5 units to the right. And then for the third one, the triangles, it was a rotation. It was either a 90-degree clockwise or a 270-degree counterclockwise rotation. Either one would work on the quiz, the test, I mean. Just remember, if you're not told, it's always counterclockwise. Okay, here's 3 more. Again, what type of transformation occurred to get the new image? Enter that in the Edpuzzle, and then come back and check and see how you did. Okay, again, first one was a rotation, either 90-degree clockwise or 270-degree counterclockwise. Second one, sorry, reflection over the y-axis. We see the points on the y-axis didn't move, so that's on the y-axis. And then the third one was a reflection over the x-axis. Does that make sense to everyone? Does everybody see that? Awesome. All right, again, more review. We're asking you to graph the pre-image, which is the points you see. Then it tells you what type of transformation to do. The first one is a reflection across Y. Second one is a 270-degree counterclockwise rotation. Then graph your new image and check and see how you did. I'm going to ask you to enter the points of the new image into Edpuzzle. Okay, so this is what your new shapes should have looked like. The red is the original, the blue is the new. Did everybody get those? Okay. Another one again, graph the original shape, the points you see. Then they're asking for translation. I will ask you to enter the new coordinates of the new shape into Edpuzzle, and then come back and check and see that you graphed it correctly. All right, this is what you should have gotten. Again, where red is the original, blue is the new. This was the translation vector. It was left 4, down 3. Does that make sense? Okay. And then this, I believe, is the last one, the trapezoid. We want you to graph it, then do the 90-degree rotation. Again, I want you to enter the coordinates into Edpuzzle for the new spots, and then come back and check and see how you did. Okay, so here's what you should have had for your new points. Remember the 90-degree counterclockwise rotation. The X and Y from my original point converts to the opposite of the Y for the X, and then the X for the Y of the new coordinate. Does that make sense to everyone? So these are the points you should have gotten. That's what the new thing looked like. Again, red was new, original, blue is new. How did we do? Did everybody do well on this? All right. So that is the end of our dilations and stuff. What we're going to work on tomorrow during the online class, the Zoom call, is a review of all the material we've covered in this unit. So we'll kind of hit on everything that we've done: points, lines, and planes, segment addition, line segments, angle relationships, angle segment or angle addition, parallel lines and transversals, corresponding angles and all that stuff, and then some stuff on this translations and things, and the shapes again, areas and perimeters and surface areas and volumes. And then for homework tomorrow will be to start on the review packet for the test. Then, like I say, the test will be in class Friday and Monday for those in school, the written part, and then online for those people at home, again, on the Friday and Monday. So I will talk to everybody tomorrow. Have a good night.